NEC Section 314.16 addresses box fill calculations, a critical aspect of electrical installations. This section dictates the maximum number of conductors, devices, and fittings allowed within an electrical box. The goal is to prevent overcrowding, which can lead to overheating, insulation damage, and potential fire hazards. When working with electrical boxes, adherence to these fill requirements is non-negotiable. For a 14/2 cable with a ground wire, the code recognizes the need to account for the volume that these conductors occupy within the box. A 14/2 cable contains 2 current-carrying conductors and 1 grounding conductor. These conductors contribute to the overall box fill calculation. Typically, a standard electrical device such as a switch or receptacle also has a fill requirement. The volume that the device occupies inside the box needs to be considered when determining whether the box meets the requirements in Section 314.16. A key consideration is the total fill capacity. This represents the maximum volume, expressed in cubic inches, that the electrical box can safely accommodate. The total fill capacity is determined by adding up the individual fill contributions from all the conductors, devices, and fittings present within the box. The manufacturers claim that a device should be counted as one conductor is not substantiated by the NEC. The NEC provides specific guidelines for calculating box fill, and these guidelines must be followed to ensure code compliance and safety. In situations where a 1.5-inch deep box is used, there are common applications and limitations to consider. These boxes might be suitable for specific scenarios, but they often have limited fill capacity, making it crucial to carefully assess the fill requirements of the intended installation. These boxes can be used for switches with shallow backs, where the device itself occupies minimal space within the box. They can also be used as junction boxes for low-voltage systems such as doorbell wiring, where the number of conductors is typically small. They can be used in non-habitable areas, such as attics or crawl spaces, but only if the box fill requirements are still met. If you encounter a situation with insufficient fill capacity, meaning that the total fill requirement exceeds the box's capacity, several solutions can be considered. Firstly, use a deeper box. Replacing the existing 1.5-inch deep box with a deeper box, such as a 2-inch or 2 and 1/8-inch deep box, will provide significantly more fill capacity. This is often the simplest and most effective solution. Secondly, reduce the number of conductors. Evaluate the wiring configuration and determine if it's possible to reduce the number of conductors entering the box. Using cables with fewer conductors if possible will help reduce the overall fill requirement. For instance, if a 14/3 cable is not necessary, using a 14/2 cable would eliminate one conductor from the calculation. Thirdly, use a device with a smaller footprint. Select devices that have a smaller physical size or require less fill capacity. Some manufacturers offer compact switches and receptacles that are designed to minimize the space they occupy within the box. Fourthly, install a box extension. A box extension is a device that attaches to the existing box, effectively increasing its volume and fill capacity. This option avoids the need to completely replace the existing box, which can be advantageous in certain situations. It is important to consult with a qualified electrician. Box fill calculations can be complex, and it's essential to ensure that all applicable codes and regulations are followed. Seeking guidance from a qualified electrician will help you determine the best solution for the specific application and ensure a safe and compliant electrical installation. When performing box fill calculations, start by identifying the number and size of all conductors entering the box. This includes all current carrying conductors, neutral conductors, and grounding conductors. Each conductor contributes to the overall fill calculation based on its size. Refer to NEC Table 314.16 to determine the volume allowance for each conductor size. For example, a number 14 American wire gauge conductor requires 2.0 cubic inches of free space within the box, while a number 12 American wire gauge conductor requires 2.25 cubic inches. Count the total number of conductors of each size and multiply by the corresponding volume allowance. Next, account for all devices and fittings installed within the box. This includes switches, receptacles, equipment grounding conductors, internal cable clamps, and support fittings. Each device and fitting also contributes to the overall fill calculation. For devices, double the volume allowance for the largest conductor entering the box. For example, if the box contains number 14 American wire gauge conductors, the device will be counted as 4.0 cubic inches. For fittings, refer to NEC section 314.16b3 to determine the appropriate volume allowance. Add up the volume allowances for all conductors, devices, and fittings. This sum represents the total fill requirement for the box. Compare the total fill requirement to the maximum box volume listed in the box's labeling. The box volume is typically stamped or printed on the inside of the box. If the total fill requirement exceeds the maximum box volume, the installation violates NEC section 314.16b and must be corrected. Some boxes are marked with a cubic inch capacity. For example, a metal 4-inch square box that is 1.5 inches deep typically has a volume of 21 cubic inches. A plastic box of similar dimensions might have a slightly larger volume. When performing box fill calculations, it is important to consider several additional factors. Firstly, cable connectors. Cable connectors that enter the box from the outside are not counted as conductors for box fill purposes, but connectors that are inside the box do count. Secondly, equipment grounding conductors. Equipment grounding conductors are counted based on the number of conductors entering the box, not the number of grounding conductors themselves. If there are 4 or fewer equipment grounding conductors, they are counted as one conductor based on the largest conductor entering the box. If there are more than 4 equipment grounding conductors, they are counted as the actual number of conductors. Thirdly, conductor fill. Conductors that originate and terminate within the box, such as pigtails, are not counted for box fill purposes. However, conductors that pass through the box without being spliced or terminated are counted as one conductor. Fourthly, device markings. Some devices are marked with their cubic inch volume. If a device is marked, use the marked volume for box fill calculations. If a device is not marked, use the default volume based on the largest conductor entering the box. Fifthly, box extensions. Box extensions can be used to increase the volume of an existing box. When using a box extension, the volume of the extension is added to the volume of the existing box to determine the total box volume. Sixthly, round boxes. Round boxes have the same fill requirements as square or rectangular boxes of the same volume. When performing box fill calculations, it is essential to use accurate measurements and to consult the latest edition of the NEC. The NEC is updated every 3 years, and changes to box fill requirements may occur. It is also important to note that local codes and regulations may have additional requirements or restrictions. In addition to the basic box fill requirements outlined in NEC section 314.16b, there are several other factors to consider when selecting and installing electrical boxes. Firstly, box type. Electrical boxes are available in a variety of materials, shapes, and sizes. The type of box selected should be appropriate for the specific application. Metal boxes are typically used for surface-mounted wiring, while non-metallic boxes are typically used for concealed wiring. Secondly, box size. The size of the box should be large enough to accommodate all of the conductors, devices, and fittings that will be installed in the box. The box should also be sized to provide adequate working space for making connections. Thirdly, box location. The location of the box should be accessible for future maintenance and repairs. The box should also be located in a dry location to prevent corrosion and electrical hazards. Fourthly, box support. The box should be securely supported to prevent it from moving or falling. The support should be strong enough to withstand the weight of the box and its contents. Fifthly, box grounding. Metal boxes must be grounded to provide a path for fault current to return to the source. The grounding conductor should be connected to the box using a grounding screw or clip. Sixthly, box covers. Box covers should be installed on all electrical boxes to protect the conductors and devices from damage and to prevent accidental contact with live parts. Box covers should be appropriate for the environment in which they are installed. For example, weatherproof covers should be used in wet locations. Seventhly, box identification. Electrical boxes should be identified with their voltage rating and the type of wiring system they are used with. This information can be helpful for future maintenance and repairs. When installing electrical boxes, it is important to follow all applicable codes and regulations. Failure to comply with these requirements can result in electrical hazards and code violations. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It is important to check with the local electrical inspector to determine the specific requirements for your area. When working with electricity, it is always important to exercise caution. Electricity can be dangerous, and it is important to take steps to protect yourself from electrical shock. Firstly, always turn off the power before working on any electrical circuit. Secondly, use insulated tools. Thirdly, wear rubber gloves and safety glasses. Fourthly, never work in wet conditions. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Electrical work should only be performed by qualified individuals who have the training and experience necessary to do the job safely and correctly. Improper electrical work can be dangerous and can result in fire, injury, or death. Therefore, it is important to take electrical safety seriously and to follow all applicable codes and regulations. Remember, electrical safety is everyone's responsibility. By following these simple tips, you can help to prevent electrical accidents and keep yourself and others safe. The NEC specifies that the volume of a box includes the space within the box up to the plane of the opening where the conductors enter. This means that any space within the box that is obstructed by devices or fittings is not included in the volume calculation. The NEC also provides specific rules for calculating the volume of boxes that are not rectangular or square. For example, the volume of a round box is calculated using the formula for the volume of a cylinder. When selecting an electrical box, it is important to consider the type of wiring system that will be used. Different wiring systems have different requirements for box fill. For example, non-metallic sheath cable requires more box fill than armored cable. It is also important to consider the environment in which the box will be installed. Boxes that are installed in wet locations must be rated for wet locations. Boxes that are installed in hazardous locations must be rated for hazardous locations. The NEC also provides specific rules for the installation of electrical boxes in fire-rated walls and ceilings. These rules are designed to prevent the spread of fire through the electrical boxes. When installing electrical boxes in fire-rated walls and ceilings, it is important to use fire-rated boxes and to seal the boxes with fire-rated caulk. The NEC also provides specific rules for the installation of electrical boxes in accessible attics and crawl spaces. These rules are designed to prevent the boxes from being damaged by rodents or other pests. When installing electrical boxes in accessible attics and crawl spaces, it is important to use boxes that are rodent resistant and to protect the boxes from physical damage. The NEC also provides specific rules for the installation of electrical boxes in manufactured homes. These rules are designed to ensure that the electrical boxes are properly installed and grounded. When installing electrical boxes in manufactured homes, it is important to follow all of the manufacturer's instructions. The NEC also provides specific rules for the installation of electrical boxes in recreational vehicles. These rules are designed to ensure that the electrical boxes are properly installed and grounded. When installing electrical boxes in recreational vehicles, it is important to follow all of the manufacturer's instructions. The NEC also provides specific rules for the installation of electrical boxes in swimming pools. These rules are designed to prevent electrical shock hazards. When installing electrical boxes in swimming pools, it is important to follow all of the NEC requirements for swimming pool electrical systems. The NEC is a complex and comprehensive document, and it is important to consult the NEC whenever performing electrical work. The NEC is available for purchase from the National Fire Protection Association. In addition to the NEC, there are many other resources available to help you learn about electrical safety. These resources include books, articles, websites, and training courses. By taking the time to learn about electrical safety, you can help to prevent electrical accidents and keep yourself and others safe. Understanding box fill requirements is crucial for safe electrical installations. The NEC provides clear guidelines to prevent overcrowding, overheating, and potential fire hazards. Always calculate box fill accurately, considering conductors, devices, and fittings. When in doubt, consult a qualified electrician to ensure compliance with all applicable codes and regulations. In summary, box fill calculation starts with identifying the conductors in the box, which is inclusive of current carrying conductors, neutral conductors, and grounding conductors. The NEC prescribes the volume allowance for each of the conductor sizes, which must be obtained from the table. The device or fitting must also be factored into the sum, as per NEC requirement. The grand total of the sum must be lower than the box's marking, as this represents its fill capacity. Remember that cable connectors, equipment grounding conductors, and conductor fill also have rules to follow when performing box fill calculations.